So yeah, so this unit has popped the fuse, so that compressor does need to be changed out and repaired. Hello everybody, welcome back to the channel. I'd like to thank everybody for pulling in and stopping by. So what are we looking at here? We're looking at a Rotor air conditioning package unit. This package unit is a dead body in its current state. So what we need to do here is we need to get this thing powered up for further troubleshooting. Now this unit had actually went out. It was installed in a piece of high volume equipment, and this package unit is actually in charge of keeping all the main components, basically the motor drive center on a large piece of equipment. It's responsible for keeping the motor drive center cool. So I say that to say this, that if this unit is to die in a spot, we have to remove it and install a new package unit. So now that this unit has been removed, it's time to troubleshoot forward and find out what the source of the failure is in order to get that part replaced and get that part repaired if possible. So now we got to do a determination on, is the repair worth the price of the unit? And that's what we have to find out today. So in order to even find that out, I got several variables that I need to figure out and go through. I need to figure out if this unit, what is wrong with it. And I believe at the moment, because I was the one to do the initial troubleshooting and the removal and the replacement, the compressor in this package unit was in a locked rotor condition. So that means the compressor had power to it, but the motor, the actual motor of the scroll was seized. Scroll or piston, I'm not sure, I have to look at it. So anyways, so where are we gonna start? We're gonna start and try to figure out how we could get this unit powered up, essentially on a test bench. So my power source is going to be coming from an old eliminated circuit, which is here. This is off a 20 amp breaker, but we had it fused for 15 amps. So this is a 30 amp disconnect on a 20 amp breaker, and it is fused for 15 amps. So I'm going to be using this power source. So I'm gonna disconnect this nipple right here, and I'll be using this power source with a little portable whip to come into our terminal block right here. Okay, so we are back, and I have the actual drawing for this particular unit. So our first one, terminal 1 and 2, it says that it is a door limit switch. Without door limit switch, terminal 1 and 2 is open. Yeah, so we have a door limit switch, and then we have terminals 3, 4, and 5, which add up to K2, KX, and K1. So we will look at K2, KX, and K1. So K1 is a relay collective fault 1, and K2 is a relay collective fault 2. And then it looks like the KX is, based off of this, is just a common. So we will begin to wire this thing up, and we will be using those terminals in order to start this unit for the troubleshooting purposes. So here we are at a terminated piece of equipment, and I am going to utilize this power source in order to power up this package unit. So all I want to do is I want to cut the junction, because this is no longer being utilized, and it is absolutely disconnected, and it has no further function or no further use. So yeah, the source wiring for this unit has been removed, and the output wiring for this unit has been removed, as well as the fuses. So what I'm going to do is I'm going to go ahead and cut this junction right here in the middle, and then I will be using this to power up this. So let me go ahead and chop out this junction and this nipple. Okay, so now that we got the nipple cut out, I can remove my little fitting, and I'm gonna want to install this fitting in order to hold my SO cable into this panel so that I can make the connection to power up this unit. So there it is. We have all 3 of our wires landed. So when it is time, we'll go ahead and flip the main breaker on, and we'll go ahead and land some fusing in here, and then we'll throw our disconnect after we get this portion of the SO cord stripped and fastened to one of these bolts, and then we will get it wired into this for testing purposes. Okay, so now that we have the unit all wired in, I have the door switch jumpered. We're gonna go ahead and power it up and verify that we have voltage on all 3 legs. Now we see our temperature control unit on, and we have 2 alarms to start with. So we'll go ahead and find out what those 2 alarms are and go from there. Okay, so we are back, and we have now printed out our alarm page. So we have alarms A1 through A19. And according to the display, one of our alarms was A1, which is saying enclosure door is open, which is something with this jumper. So we'll go ahead and figure that out. And then the second alarm is A17, which is phase monitoring. So it looks like we're gonna have to reverse 2 of the phases in order to get rid of one of those alarms, and then we will work on the door alarm. Okay, so I have removed my jumper for the door, and I have swapped 2 phase leads. I'm gonna go ahead and power it back up, and let's see what those alarms look like. So we no longer have any alarm issues, and we have our evaporator fan operational. So this evaporator fan is pulling in air to circulate and pushing out air right here. The only issue is I have the compressor disconnected, so we will go ahead and plug our compressor back in and see what the circuit looks like. Since the compressor was the locked rotor issue, everything else is functional with the exception of the compressor. So I'm going to go ahead and open up the compressor chamber, and I'll go ahead and get that back installed, and then we will see what the amperage looks like on the compressor. So now that we got the terminals back onto the compressor, I will go ahead and check the unit to ground. So the first terminal, I will check it to ground right here. No. We will check the second terminal to ground, and we will check the third terminal to ground. So the compressor is not grounded out. I just believe it is a locked rotor. So I'll go ahead and get the cover cap back on, and then we'll get this unit cycled on and see if the status has not changed of it, which I'm positive that it has not, and we will go ahead and see that. So it is not calling for cool because our set point is, our temperature is below the set point value. So let me go ahead and lower that. So now I have lowered my set point, and we'll check the current, and it should be calling for the compressor here anytime now. Okay, so our condenser fan has kicked on. So yeah, so this unit has popped the fuse. So the compressor does need to be changed out and repaired. So when the unit tried to throw on the compressor, it did take out one of those 10 amp fuses, which was expected. So this unit is going to need a compressor replacement. So now we will start the procedure of opening up the unit, evacuating the refrigerant, and once we evacuate the refrigerant, we will remove the compressor. But before we do that, we will have to determine if it is cost effective to replace the compressor on this unit, or if this unit will be scrapped. And that is not my determination. I will go ahead and see, I will go ahead and get some pricing in order to figure out you know, what the next step is. We will see what a brand new compressor costs. And this unit actually uses, what is the refrigerant? So this unit uses R134A, and it is essentially 34 ounces of refrigerant, plus the cost of the compressor, and plus about 4 or 5 hours of labor to swap that out. So there it is. So this unit is in the condition that I'm pretty sure it was in. I was more than willing to sacrifice a 10 amp fuse, which we blew A phase. Not a problem. and I was expecting that. So as expected, this unit is not ready to run. We will need to purchase a new compressor for it, and I just really wanted to get this on video so everybody can see the process on how to bench test a unit that is determined to be bad. We weren't really sure in the moment, but the idea was to replace the unit in the moment since it was not functioning on the piece of equipment that this unit came off of. So with that being said, I'd like to thank everybody for watching and for tuning in, and I hope everyone or somebody has got something out of learning the process on how to find the manual, consider the wiring terminals, and then basically power up and bench test a unit. So I will get a compressor priced out for this unit, and we will go from there. So I thank everybody for watching, and I will see you on the next one. Stay safe.